Hello y'all, we are Memphis Communiversity and today we're doing another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to do is we're going to be continuing our adventure of the Fundamental Theorem of Calculus, the most important concept that we learn of course in calculus. And what we're going to do is we're going to take what we learned in the previous video where we introduced the Fundamental Theorem of Calculus, and what we're going to do is we're going to use that formula along with a derivative at a given point to learn information about the antiderivative, whether that be the antiderivative itself or the antiderivative evaluated at a point. So let's just get started. I'm way too excited. It's the Fundamental Theorem of Calculus. Let's get going. So let's call this lesson the Fundamental Theorem of Calculus formula. So Fundamental Theorem of Calculus formula. Let's see if I can squeeze the word formula in here. Formula. So it uses the same thing as we talked about in the previous video. The integral of a derivative is that function evaluated at the upper limit minus the lower limit. Or another way to say that is the integral of f is the antiderivative of f evaluated at the upper limit minus the lower limit. So what we're going to do is, in these questions, the givens are always going to be the same. And this is how we know that we have a Fundamental Theorem of Calculus question. What it's going to be is two givens. The first given is going to be something about the derivative. So we'll just say, here's the derivative, blah, 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 blah. Or here's a graph of the derivative. Or here is velocity, and you want to find position, and velocity is the derivative of position. You're also going to have an initial point. We're going to call that f of a equals number. So then the givens will look something like f prime of x equals 2x, and f of 4 equals 7, something like that. And from there, we would just know immediately, boom, 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 it's the Fundamental Theorem of Calculus. And what sort of format questions do they ask? The more common one is going to be right here. So what it's going to be is f of b equals number plus integral of f prime of x dx from a to b. So sometimes they're going to say, here's f prime, here's f of a number, find f at a different number. And this is going to be a very common question. This is actually the Fundamental Theorem of Calculus formula that we talked about in the previous video. Because if you take this number and bring it to the other side, we would have f of b minus f of a, and that's the normal formula. F of b minus f of a equals the integral of f prime. What I like to do is I just like to bring that f of a to the other side. That's why we have the pound sign here. I think this is called the pound sign. So we have pound sign number plus the integral. So this is the way I'm going to set it up. Let me tell you how the givens work, which is in the what questions. So this a is going to be the given x. Let's put it over here. Let's label it over here because I want some space. Hopefully you can read this. I'm writing a little bit small because I want to write a little put some formulas down. But this will be always my given x. This b right here is going to be my want x. Let's put it right here. And then this number right here is the given y value. Given y value. And then the want value is the 7. So this is how I'm going to set it up every single time because I want to do the same thing every single time. So always my given x is on the bottom. So this number right here will be on the bottom. This want x will be on the top, and then we'll have the given y. Some teachers potentially teach always the bigger number on top, and that's perfectly fine. But I'm going to set it up this way because this way I can do the same thing every single time. And what I'm going to see is that I don't really have to worry about the smaller number being on top except in one scenario, which will be area. So let's talk about this. How do you actually compute this guy? Well, obviously we're going to do a couple of examples. That's why we're having fun, of course. But there's going to be several ways to do this integral depending on the situation. So perhaps the most common way is just we're going to take antiderivatives, plug in the top minus at the bottom, apply the Fundamental Theorem of Calculus just like we did in the previous video. So this is going to be our first main way. We'll just call it antiderivative. The second main way, if we're very, very lucky, will just be a calculator. And that's obviously the best way because you can just plug it in a calculator. So that's going to be one way. One way is going to be area because we're going to have a graph of f prime. So we're going to find the area between point A and point B. So that'll be area. And then finally, the last way is perhaps we don't want to find the integral itself, but we're being lazy, so we're going to approximate it with a Riemann sum. That's usually given in a table. So perhaps we'll be doing a Riemann sum. So this is the formula. Before we go on, I just want to really stress this because this is the most important thing you'll ever hear in your entire life maybe. So the given will always be a derivative, and f of a number equals another number. Give an f of an x equals a y value, and we're going to set it up always in this way. The number we want, the antiderivative evaluated at the number we want, is going to be the given y. That's given. We're going to put our given x just right here. We're going to put our want x on top, and then we're going to set up this integral. What we're going to do is we're going to take this integral depending on how the given is given. So like, for example, we'll be taking an antiderivative, we'll be typing in a calculator maybe, we'll be finding areas and things like that. And then don't forget though, please don't forget, you have to add this number to whatever the integral value is. So that's why integrals and antiderivatives are slightly harder than derivatives. For derivatives, if you want to evaluate at a point, you just take the derivative and plug in the number. For this, because there's two x's involved, you have to take the integral and then add the given y. Hopefully this one makes sense as we go. But sometimes you don't just want to find f of a number, you want to find the entire antiderivative no matter what the function is. So what we're going to do in those cases, because we don't want the f value, the antiderivative at a certain number, we're going to use an indefinite integral instead. So we're just going to have the integral of f prime of x. In these questions, it's going to usually be an antiderivative, and we're going to take the antiderivative. So we're going to take the antiderivative. But in this case, because we have an indefinite integral, what we're going to do is we're going to write plus c, because again, every function has an infinite number of antiderivatives, and what we're going to try to do is we're going to try to find what specific antiderivative do I want to do, and we'll see examples of this. And how you do that is you're going to plug in this initial point. So plug in f of a equals the number to find the plus c. And we'll see this. This question isn't used as much as this one. This question, this Fundamental Theorem of Calculus formula question, this appears in several free response questions on the AP exam. For example, accumulation free response questions, or rate in, rate out free response questions, graph free response questions, table free response questions, particle motion free response questions, parametric if you're taking BC. So all of these free response questions include this question. So this is why this is the most important formula on the calculus exam. But sometimes you'll do this, especially in college classes. You'll be taking antiderivatives, and we're going to be doing examples of both of this. So again, time to do the Fundamental Theorem of Calculus. How fun, of course. Fundamental Theorem of Calculus. You can spot it from a mile away because they say, here's a derivative, here's an initial point, and then they want you to find f of another number. Set up. Number plus integral, given x on the bottom, want x on top. We don't have to worry about the position of the numbers. You'll see only when we do area. Area has to have the smaller number on the bottom. We'll talk about that when we get there, but let's get going. Way too excited. Let's get going for some examples. So I'm going to erase this. Hopefully you got that copied down. If not, you can use the power of technology to rewind the video, I believe. Let's get going though. Let's do two different questions. So let's say we'll keep it easy with our antiderivatives because in the last video we focused on antiderivatives. Today we're just trying to use the formula. So let's say we had two givens here. Given f prime of x equals, again, we're going to try to keep it simple. So let's just keep it as 4x plus 1. And then they also tell me, because they have to tell me, they have to give me an initial point, and you'll get very accustomed to this. They'll always say, here's a derivative, here's an initial point, do math. So it's going to say something like f of 2 equals 3. So these are going to be my givens. It's not just one given. They give you the derivative, they give you the f. And in calculus, there's only two questions. Here's a function, take a derivative, and then, or here's a derivative, whose derivative is this? This is this latter question. This is the more fun question. But in order to do this question, we need f of 2 equals 3. So we're going to answer two questions here. The first question I'm going to answer is, what is f of 4? So this is going to be my first question. Hopefully I can do this, of course. And then my second question is going to be find f of x in general. So hopefully you can see what the difference between these questions. This question, it's going to be a number as the answer. What is f of 4? What number is it? And then this question, it's going to include x's. It's the actual formula for f of x. And again, we'll do it slightly different, but we'll use the givens every time, and we'll have to do this integral eventually. So, time for the setup. And let's just be very, very, very careful with the setup. We can do this, friends. Just set it up the way that I described earlier. So what it is I'm going to write it right here. Let's actually make this f of 4 smaller and write it on this side, save some space. So what I do is you always write the given y, so that's going to be 3. Then you write plus, because we're just moving, in the fundamental theorem of calculus, it would be f of 4 minus f of 2, where you just bring the 3 to this side. You have the integral of f prime, so let's list out what f prime is. Let's not forget our dx. And then, again, the two numbers on the integral are the hardest thing to place and position. But remember, I always want the given x on the bottom, so I'm going to put 2 here. And I always want the given, the want x. What x do I want to find the function at? Sorry, I lost my train of thought there. But the want x always on top. So given x, want x, which is 4, given y at this place, and this is the formula. The initial y plus the integral, where the given x is on the bottom, the want x is on top. So now we set it up. We look at this question. Perhaps if we were lucky enough, we would type it in a calculator, but I don't have a calculator with me. If we had a picture, we would try to graph this and try to find the area of this. If we had a table, we might be doing Riemann sums, but here we're going to do antiderivatives. Just keep in mind that this 3 plus is outside of the integral. So when we take the antiderivative, we're going to plug in the top number like minus the bottom number like normal, and then at the very end, we're going to add 3. Just don't forget that this 3 is here. That's the entire point of why we're doing this. So try to practice this integral right now. Remember, it's the power rule. You add 1 to the new exponent to form the new exponent, and then you divide by that new exponent. So what's 4x? Well, it'll become x squared. We're going to divide by this new exponent. If you divide by the 2, 4 divided by 2, I believe is 2. So we're going to write 2 here. And then what's the integral of plus 1? Remember, the integral of any constant is that constant times x, like the antiderivative of 7 is 7x. The antiderivative of 1 here is just 1x. 1x. And then I'm going to use vertical bar notation. Again, after you set up this integral, you just have to do the integral. So let's see here. Well, we have 3 plus, and then we're going to do top minus bottom. But notice as I do top minus bottom, I don't incorporate the 3. The 3 plus is just on the side here because it's an outside of the integral. So when I do this, same thing as normal, top minus bottom. So when you plug in 4, it's going to be 16. 16 times 2, I believe, is 32. Plus 4, just plugging in 4, plugging in 2. So when we plug in 2, 2 times 2 is 4, times another 2 is 8. 8 plus 2 is 10. So it looks like we are done here. Let's see if I can do any math. 36 plus 3 is 39. 39 minus 10 is 29, I believe. So this is our final answer. So again, let me recap this for you. It's so beautiful, such an important question. Let's see what we did. So remember, always the given in these questions is a derivative and an initial point, x comma y. So how you set it up is you take the integral of that derivative, you put the given x on the bottom here, so that's the given x. You put the want x on the top, and then you don't forget to add the initial value. This is where the fundamental theorem of calculus. And then once you have the formula set up with the integral, you just take the integral, however the givens are given to you, whatever sort of tools are at your disposal. In this case, we can just take the antiderivative, so that's what we did, using the power rule. Then we plugged in top minus bottom, we added 3, and then we were good to go. How lovely, you're going to be doing this process so many times. You're going to learn to love this process. Don't know what I'm talking about anymore. Let's do this question. So this question is a little bit different. This question again is going to have x's in it. It's the formula for f of x no matter what the number is. So how I like to do this question again is I don't incorporate this until the end. I still will use this like I did in this question. But in this question, I use it at the very beginning. I wrote this 3 down. In this question, I'm going to just leave it aside, not forget about it. It's going to be okay. We're going to worry about him later. He's going to get his time. But for now, I'm going to write what is called an indefinite integral, meaning that there's no numbers on the integral itself. So it's going to be 4x plus 1 dx. And then usually in these questions, you're going to take an antiderivative, whereas this question, because it's a definite integral, it does have numbers. There will be multiple ways to do the integral. So in this case, what is the integral of 4x plus 1? Well, that's going to be 2x squared plus x. It's the same antiderivative here. But in this case, what you want to remember, of course, is the plus c. We're trying to find the specific antiderivative that makes this true. Over here, we don't need the plus c because when you do top minus bottom, the plus c's would cancel. So, in the first half of the question, when you do this setup, you use the initial point immediately. And in this one, you use the initial point 2, 3 at the end. So what we're going to do is here, we're going to plug in 2 for x. So it's going to be 2 for x. So it's going to be this setup right here. And what we're doing is we're solving for c, of course. And then what's on this side? Well, we plug in f of 2. That's going to be 3. So the y goes over here. We plugged in x's. Looks like we are going to get 4 times 2, which is 8. 8 plus 2 is 10. 3 minus 10. We can just do more steps. So c is -7. Keep in mind that c is not the answer. The answer is this thing right here replaced with -7. So if I had more board space, what I would write is 2x squared plus x minus 7. But I'm just going to write this plus c, and I'm going to replace it with -7. And that's how it works. Let's see if it works for this number in particular. Well, what is this? This is f of 4. So let's plug in 4 here. It'll be 4 times squared, which is 16, times 2 is 32. 32 plus 4 is 36, minus 7 is 29. So that's how you do fundamental theorem of calculus. This is the most important example. Given derivative, given point, no matter what question you're doing, you're using the given point at the beginning. For this one, you use it at the beginning. For this one, what you do is you use it at the end. But you always use both of these informations. You need to listen very carefully. You should be able to spot the fundamental theorem of calculus from a mile away because it just, here's a derivative, here's an f value, go for another f value. So let's practice this, and in the context of other questions, as promised, let's try to do an area question and then maybe a Riemann sum question, and then finally, let's do some particle motion. So I'm gonna erase this. Lovely work, lovely, lovely. How exciting. Hopefully we'll incorporate all the examples of potential FTC questions, especially on the AP exam, no matter if you're taking A, B, or BC. So I'm going to draw a lovely picture. Please don't be too impressed by my artistic ability. So I have this. Let's draw a fairly simple picture. This will be the point 1. This will be the point 2. We'll have this line. We'll go down 2. And then what if we, over here, we go down 1 immediately, and then we'll go down 1 here, -2. So this is going to be my nice little picture here, not too complicated. And here, this graph is f prime. Obviously, this is supposed to be a straight line. What are you going to do? And then, again, in these givens, there are always 2 givens, not just the derivative, but also an initial point. So they have to tell you initial point. Let's say that f of, let's say 0 is equal to 6. So this is an initial point that is given. You don't get to come up with this. This is the entire information that they get. And what we're going to do is we are going to try to set up the fundamental theorem of calculus twice. So first off, what we're going to do is we're going to try to find f of 2. And then once we get confident about that, we are going to try to find f of -2. So 2 questions, and if you know graph responses questions very well, which appear on the AP exam every single year basically, you'll know that oftentimes they do ask 2 questions, and I'll tell you why they ask 2 of the very similar questions. So let's start off with this, f of 2. Again, fundamental theorem of calculus, because they give us something about the derivative and an initial point. So let's set up this bad boy right here. So f of 2, this is the given, this is the want x. So it's always the given y, so it's going to be 6 plus the integral. Okay, so now let's try to put the numbers on the integral. So remember that the given x goes on the bottom, the want x goes on top. So the given x goes here, 2. Oh, that's not the given x is 0. Let's be a little bit more careful. So the given x is 0 actually, and the want x is 2. I want to find f, the antiderivative, at 2. What's the function here? Well, this function is just going to be f prime dx. Hopefully you can tell that this 2 is not part of the picture. The picture ends at this point right here. So here we go. How do you do this? Well, now that we set it up in the exact same way as the previous question, given y, given x, want x, Now we're ready to evaluate the integral. We're not going to forget to add 6 because this is the entire point of why we're doing this. And then how do you evaluate this integral with a picture? Well, we're going to find area. So what we're going to do is we're going to try to find the area. Of course, you don't find the area of the entire graph. You find the area between these 2 points, 0 and 2. So we're going to find the area from 0 to 2. Looks like it's a trapezoid. You can also break this up into a rectangle triangle combination. I'm going to do that because I like that better. So it's going to be 6. A lot of times my students will want to write 6 plus area. Perfectly fine. So it's going to be 6 plus, well, what's this rectangle? Which is 1 times 2. So that's going to be 2. This triangle, notice, is half of this rectangle. It's 1 times 2 divided by 2 plus 1. So it looks like we have 9 in this case. So again, same setup as before, but once you have the integral set up, you just evaluate it with however you need to do it. Just try to survive, just try to do your best. In this case, because we have a graph, we'll find area. Area wasn't too bad, it was the area of this point to this point. But no matter what, we know the setup. 6 plus the integral, bottom number to top number, f prime. So now we're going to do a very similar question. You might be wondering, why are you asking me a question that's so similar? And you'll see why. Oh, it requires one additional thing. So now what we're going to do is we're going to find f of negative 2. Still though, it's the same setup. It's the given y, so it's going to be 6 plus the integral, still f prime of x. But it's the numbers on the integral that are changing. Oh no, but it's going to be okay. Because we're going to, I'm with you here, I'm going to help you through this. So the given x, always on the bottom, so it's going to be 0. The want x in this case is no longer 2, it's now negative 2. Oh no, oh no, oh no. We have a smaller number on the top, but it's going to be okay. What we're going to do is we're just going to negate the integral. What I want to mention here is that if we didn't have to do area, we could just leave it like this. For example, if we're doing antiderivatives, we could just take the antiderivatives. We wouldn't have to negate the integral. Same thing if we were using a calculator, for example. But if you're evaluating an integral by area, by definition, you need the smaller number to be on bottom. So all we're going to do after we set the formula is just do one additional step. We're just going to flip the integral. And what does it mean to flip an integral? Well, if you watched our integral properties video, that means you have to negate the integral. So what we're going to do is we're going to write 6 instead of plus the integral. It's going to now be minus the integral from negative 2 to 0. F prime of x dx. So again, I still always try to set up the formula the same way. But if potentially, if I do get a smaller number on the top, I do negate the integral in the second step. So now what we're going to do is the same thing. We need to evaluate this integral, but instead of 6 plus area, it's going to be 6 minus the area. Nothing too crazy here. 6 minus the area. So just one additional step again, negating. Just keep in mind that we're still doing area the same way we did area under the graph in a previous video. Anything under the curve is considered negative area. Anything above the curve is considered, or above the x-axis is considered positive area. So keep in mind in this case, we're finding the area of this triangle and this triangle. This will be negative and this will be positive. This is negative because it's underneath the x-axis. This is positive. Keep in mind that it's always between the function and the x-axis, so you're not finding like this area, for example. But because there's going to be negatives and positives, what I like to do is I just like to find the area first and put it and wrap it around parentheses so that it knows that it's safe. Don't try to have all the negatives all at once. So let's do this. What is this area? Well, this area is going to be negative 1/2 because it's 1 times 1 divided by 2 with a negative. So it's going to be negative 1/2. So again, there's just a lot of negatives in these questions. There's two main negatives. The first main negative is because sometimes area is under the curve. And then second, or area not under the curve, but under the x-axis. I keep saying that. And then one negative is because you potentially have to flip. Let's finish this question before I keep rambling on. What's the area of this triangle? Well, it's 2 times 1 times 1/2. So that's going to be 1 plus 1. So again, just notice how careful I am with parentheses. That's just the main mistake people make. 6 minus the area, just put the area in parentheses. Well, here you have 1 minus 1/2. That's going to be, of course, 1/2. If you subtract 6 from it, you'll get 5.5. 5.5. But this is the question. You'll see that, again, these appear a lot on graph free response questions. no matter what the question, once you see that it's a graph of f prime, and graph free response questions always have a graph of f prime basically, then what happens is using an initial point that they give you, you can find f at certain numbers, always set it up the same, given y, given x, want x. Potentially though, if the smaller number is on top of the integral, you do have to flip the integral, perform a little switcheroo, negate that integral, and then once you have that, you'll either have the initial y plus the area, the initial y minus the area. Just find the area slowly. It will always be the combination of rectangles, trapezoids, triangles, and semicircles, or they just tell you straight up what the area is. And just keep in mind that there is still a negative area if it's underneath the x-axis. So hopefully this makes sense. If you need more practice with this, we have so many graph free response questions videos on our channel. But for now, let's move on to a different kind of free response question that they potentially might ask, where this is incorporated, or maybe the multiple choice, and that's with Riemann sums. And you'll see that it's the same thing, so I'm going to erase this. Erase, 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 erase. So we're going to erase this, erase this. Again, this is just the most important thing. It just appears in so many different kinds of examples, which is why I'm trying to cover them all. So let's say we have this table here. X, 1, 3, 7. I'm just making up numbers, of course. 2, 5, 8, whatever. And let's say that we know this is not going to be f. Remember that in Fundamental Theorem of Calculus questions, and all these questions, the givens are something about the derivative. So in the previous question, it was a graph of the graph of the derivative, not the video. I don't know why I said that. And then this one, it's a table of the derivative. So we have information about the derivative, and we also know the fact that f of 2 equals 7. So or not f of 2, I don't know what I'm doing anymore, f of 1. So let's establish it. Let's all take a deep breath. We can do this. So again, there's always two givens, an initial point and something about the derivative. In this case, it was a table of the derivative. Then the question I want to ask myself on this lovely Wednesday evening is, what is f of a? So this is going to be the setup. Before I even look at the table, I'm going to set it up the same way with Fundamental Theorem of Calculus. What they're going to ask us to do is approximate this actually with a Riemann sum. I'm just too excited for these questions. I'm not writing actually the question. So approximate with let's do a right Riemann sum. And it's only going to be two rectangles because it's only two pairs of adjacent columns here. So we're going to approximate with the right Riemann sum. But again, what we want to find is f of 7. I don't know if I said f of 8 earlier, but it's f of 7 because I want to find f of 7. So again, same setup. So it's always the what am I doing here? It's always the given y. So the given y is this number right here. So 7. Hopefully that isn't too confusing, but it's always the given y. Then you set up the integral. The important thing is that the given x, which is this number right here, is always on the bottom, 1. The given y is always on the top. No, I don't even know what I'm saying. What am I saying? Okay, let's do this again. F of 7. The given y is right here. The given x is right here, 1. And then the want x, that's what I'm trying to say. The want x, which happens to be 7 as well, is on the top. So I'm going to repeat myself because I didn't even understand it myself. Given y is right here. It's the thing getting added to the integral. So this number goes right here. The given x goes right here. So we put the 1 down here. And what do you want to find f at? In this case, we want to find f of 7. We put this number right here. And then what do we put in the integral? That's going to be f prime of x. So here is the same formula that we've been talking about. This is the Fundamental Theorem of Calculus. Boom, boom, boom. So in the previous question, what we did is we took an area to evaluate this integral. And the previous one, we did an antiderivative. Here, what we're going to do is we're going to approximate with a right Riemann sum. So this shouldn't be too bad. Just keep in mind that sometimes I tell my students, sometimes the Riemann sum is not the answer. You have to do one additional step to find the answer. So remember that Riemann sums only approximate the integral. So that's going to be this guy right here. And then the Riemann sum will be the answer. Plus 7 of the Riemann sum will be the answer. So let's try that. So it's going to be 7 plus the Riemann sum. Remember, it's always the difference in the x's times a y value. So it's going to be 3 minus 1. That's going to be 2. And then you choose the right endpoint. So we're going to choose 5 here. So it's going to be 2 times 5. So this is the first rectangle, base times height. Then for the next rectangle, as easy, 7 minus 3, always the difference in the x's for the base, so it's going to be 4. And then you're going to choose the right endpoint's y value. So what's the right endpoint? 7. What's the y value? 8. So we do this. This is going to be 10 plus 12 plus 7. 10 plus 12 is 22. 22, again, is the Riemann sum. That would be an answer choice, but it's not the answer. They're trying to trick you. You have to add this 7 to the answer. So what's the answer here? What's 22 plus 7? I believe that's 29 again, conveniently enough. But again, what I'm trying to focus on is use the same formula every single time. Given y, want x, given x, derivative. When do you know to do this formula? When I say, here's f prime, here's f of a number. So some of my students are good enough where they're the first 3 words of the question, suppose that f of 2 equals 7. Boom, you know fundamental theorem of calculus. Suppose that f of 5 equals 3. Blah, 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 blah. Here's about the derivative. Fundamental theorem of calculus. So this has been a long video because it's fundamental theorem of calculus, but I do want to conclude with particle motion because it's a good way to practice learning these concepts. So I'm going to erase this guy again. And what we're going to do is we're going to do similar to the first question. We're going to try to do a particle motion question where the answer is just a number. And then we're also going to do one that involves a function. So how exciting. Let's end on a bang. So let's say we have this fact. Given that, again, let's just keep it pretty simple. Let's say given that the velocity of a particle is, let's just do 6t minus 2, and the particle, I don't know how to spell the word particle, is at x is equal to 3 when t is 1. So by these givens, I already know what the question will be before I even read the question because I have an initial point and then I also have something about the derivative because keep in mind this initial point's about position and what's the derivative of position? Velocity. So another similar question would be here's acceleration, here's some sort of velocity value. That's going to be fundamental theorem of calculus. So let's see, what questions do we want? What we're going to try to do is we're going to try to find the position of the particle. So find the position of the particle. The particle at t is equal to 3. And then we're going to just find the position of the particle at any time. So find the position of the particle at any time. I wrote particle of the particle. That's not what I want. Position of the particle at any time. So let's get started. So again, every single fundamental theorem of calculus question will have something about the derivative and an initial point. So let's try to change this sentence right here to an initial point. It looks like it's either going to be 1, 3 or 3, 1. But keep in mind that in particle motion questions, remember the variable that matters is time. That's going to be your independent variable. That's going to be your first coordinate. So it's not going to be 3, 1. It's going to be 1, 3. Because when you have a time, you get a position. So just don't be confused here that 3 is usually the x coordinate. That's usually the first coordinate. But in this case, it's time that's the first coordinate. X is the second coordinate. So we're going to have that. And again, in these particle motion questions, of course, it could be using particle motion words. Like, for example, if they said initially, that means the time is 0. If they said the particle is left of the origin, like 3 units left of the origin, that means the particle's position is -3. If the particle is at rest, that means the velocity is 0. Various particle motion rules that you want to be aware of. But let's set up this question. So I like to use S as my position formula variable. So it's going to be S of 3. This is what I want to find. So it's the same setup as we talked about before. It's always the, let's actually change the question. I don't know if you're allowed to do this, but I'm going to change this to a 2 because I don't want it to match this number because we matched it in the previous question, so it might get confusing. So let's try to set up the fundamental theorem of calculus in the same way as we normally do. So it's always given the dependent variable, usually it's y, but remember the dependent variable in this case is x, the function value of the initial. So in this case, we're going to have 3 here, so it's going to be 3 plus, and then it's the given t value, because that's the independent variable, that's the first coordinate on the bottom. The want t value will be on top. So in this case, it's going to be 2 and 1. And then we'll write the integral right here. So it's going to be 6t minus 2. Not my best 2 here. Let me erase it to make it a little prettier because we're doing important work here. So again, the given y value or the given function value plus the integral. The bottom number is the one you already know. So in this case, it's 1. The top number is the one you're trying to find the function at. So in this case, it's 2. How do you do this integral? Well, it's going to be like our first question. What we're going to do is we are going to take the antiderivative. So it's going to be 3 plus, what's the antiderivative of 6t? Well, again, you add 1 to your exponent. This is technically 2 to the 1, so it'll be t squared. And then you divide by your new exponent. So 6 divided by 2 is 3, so that's going to be that. What's the antiderivative of minus 2? That's, of course, minus 2t. Minus 2t. And then we plug in 2 and 1. Looks like I'm going to run out of space, so let me erase this here. Remember that you don't subtract the 3 when you do top minus bottom. So it's going to be 3 plus top minus bottom here. Not the most organized thing I've ever seen. But when we plug in 2, it shouldn't be too bad. Looks like it's 4 times 3. 4 times 3, I believe, is 12. And then minus 4, because we're plugging in 2, so it's minus 4. Just like normal when I'm doing top minus bottom, I wrap the entire bottom, the entire top with parentheses to try to keep them separate so that the negatives don't get in my way. So when we plug in 1 here, it looks like we'll just get 3 minus 2. That's not too bad. So let's finish this off. What is this? It's going to be 3 plus 8 minus 1. 3 plus 8 is 11. Minus 1 is 10. So it looks like this answer, while I don't have space, I'm just going to write it right here randomly. The answer is 10. But again, it's the same setup. You can spot it from a mile away because they give you something about the derivative. They give you an initial point, and then you're trying to find another point. So you just set it up in the same way. Given dependent variable, this coordinate right here. Given independent variable, usually x, but in this case t. This first coordinate right here. What do we want to find the position at? That's 2. That's why it goes right here. Once you set it up, just do the integral however you need to do it. In this case, it was with an antiderivative. So let's do this last question. This is the question where we are not going to use the initial point right now. We're going to use it at the very end because we can't set up the same formula because we don't want to find s at a certain number. We want to find it at any time. So I'm going to have s of t here. I use an indefinite integral instead. So no numbers, no adding as well. This plus 3 will again be incorporated at the very end. So we're just going to write 16 minus 2. We're going to take the antiderivative. The antiderivative being 3t squared minus 2t from before. The power rule, of course, add 1, t squared divided by 2, 6 divided by 2 is 3. The antiderivative minus 2 is still minus 2t. But the important thing is that when you have these indefinite integrals, an entire point, if it was on a free response question, it's just remembering the plus c. Super, super important. Remember that plus c. Then, for this question right here, we plugged in the 1 and 3 immediately where they were supposed to go. And in this one, what you do is you plug in the 1 and 3 at the very end. This is going to get very messy, but hopefully you can see what we're doing. We're going to plug in 3 into this side, so we're going to get 3 equals. We're writing kind of small here. This is not my best work. And then we plug in 1 on the other side, so it's going to be 3 minus 2 plus c. Looks like I can solve for plus c because it's pretty easy. C is equal to negative 2. So again, I'm using my initial point to find my plus c. Now it's minus 2. So at the very end, remember that the c is not the answer itself. What we're going to do is we're going to erase this plus c and replace it with minus 2. This is the specific antiderivative for this question, and we are done. So hopefully this has not been too crazy of a ride. let me just erase everything, write the Fundamental Theorem of Calculus, because it's my favorite thing in the entire world. You should have hopefully not mastered it, but at least gotten a pretty good intro. Remember, what are the givens? The givens are always something of the form f of a equals a number, and then they'll say something about the derivative, either a graph or a table, particle motion giving you v and wanting to find s, or giving you a and wanting to find v. And then the formula is f of whatever number you want equals this number here, let's call it a pound sign, and then you add the integral of f prime, as we did in several of these examples. How do we set it up? Given x will be on the bottom, a, so this is the given x, right here. Want x is on top, so we're gonna put b here. That's not my best b, let's finish strong, and then this will be my given y. So this is always the setup, the most important formula that you will encounter in calculus. And in order to do this integral of f prime, you're going to be doing various methods, perhaps taking antiderivatives. That will probably be the main method. When you have those accumulation free response questions, or particle motion free response questions, or parametric free response questions, you'll probably be using a calculator. For graph free response questions, you obviously use a area, because you find the area. And then finally, for table free response questions, you're often using a Riemann sum. But this is the formula. Love it, love it, love it. It will come up, it will become your best friend. It just comes up so often on the AP exam that I'm really, really trying to stress this. Of course, if you want more practice with this, even if this has been a very long video, you can watch our Girls Teach Calculus video, where one of my former students, she explains this again, probably better than I do, even though I get paid to do this. What she does is she goes through the formula again, and then she practices various examples. Some with taking antiderivatives, some with doing areas, and then a bunch of particle motion questions. Some of the questions are f of a number, so we do this formula right here. Some of the questions are f of x, so she has plus c's and stuff. But she sets up this formula over and over and over again and patiently works through some questions, so be on the lookout for that. If this video was useful for you, give us a like and subscribe. Our next video will be concluding the second half of the Fundamental Theorem of Calculus, the easier half of the Fundamental Theorem of Calculus, taking derivatives of functions that are defined as integrals. So be on the lookout for that. Hopefully I'll see you then. Hopefully this was useful for you. Fundamental Theorem of Calculus, best thing in the world. I hope to see you next time as we do that second half of the Fundamental Theorem of Calculus. Thank you very much.